further matrices which we are going to discuss today: symmetric, skew-symmetric, orthogonal, idempotent, nilpotent. All those matrices we are going to discuss with their properties. For a symmetric matrix, the elements above the diagonal are correspondingly equal to the elements below the diagonal. Any matrix in which we have a square is equals to identity. If I'll take a square of a matrix and it would become identity square matrix. A plus B transpose is equals to A transpose plus B transpose. So what would I do here? Hello students, welcome back to our YouTube channel Geeks for Geeks, GATE, Computer Science and Data Science. So till last class we have discussed matrices and some types of matrices. So we are left with some types of matrices which we are going to discuss today. But before that, let's just do a quick revision what we have discussed in the last class. So in last class we have started with the definition of matrices, and I have said that if I'll take some numbers and arrange them in rows and columns and cover them in square bracket, then I'll get a matrix. So let's say this I am taking and this is my matrix, right? And then I have said that the number of rows I have here 3 rows and 3 columns. So these 3 cross 3 would gives me the order of a matrix. So this 3 cross 3 is my order, right? And then I have discussed trace of a matrix. So what is trace of a matrix? Sum of diagonal entries. Sum of diagonal entries. And what is a diagonal? The middle values, right? 1, 5 and 9. So here 1, 5 and 9 would be my diagonal. So that means trace would be my 15. So we have discussed some of the properties of trace, and then moving forwards we have discussed transpose of a matrix. Transpose of a matrix. So if I'll convert rows into columns, then I'll get a transpose. So let's suppose this is my A matrix, and if I need a transpose, then that would be my 1, 2, 3, 4, 5, 6, 7, 8, 9. That means I have converted rows into columns. Then later on we have discussed some types of matrices. So I'm just writing what types of matrices we have already discussed and move forward to another type of matrices. So we have started with row matrix, right, in which we have one row, that is row matrix. Another one we have discussed column matrix, in which we have one column, that is my column matrix. Then we have discussed null matrix, in a matrix in which all the entries are 0, that would be my null matrix. And then I have discussed about square matrix. Square matrix, a matrix in which number of rows and number of columns are equal, then that would be my square matrix. Later on we have discussed lower triangular, or lower triangular se pehle we have discussed a diagonal matrix. So diagonal se bhi pehle humne we have discussed diagonal matrix. Diagonal matrix, so in which we have non-diagonal entries 0, that is my diagonal matrix. Then we have discussed scalar matrix. If we have single value, same value on all the diagonal entries of a square matrix and all non-diagonal entries are 0, then it would become my scalar matrix. And then we have discussed identity matrix. Identity matrix was that matrix in which all the diagonal entries are 1 and non-diagonal entries are 0. Then lastly we have discussed triangular matrix, lower triangular and upper triangular. Lower triangular and upper triangular, right? Lower triangular means the matrices in which elements above the diagonal are 0 are lower triangular matrix, and upper triangular the matrix in which elements below the diagonal are 0, right? That we have discussed in last class. So if you guys faced any confusion in any of the video, you can just let us know in the comment section. Okay, so yeah, you can just let us know in the comment section if you have any confusion, any doubt, and for the notes you would just check out the description, you would get the details. Now further matrices which we are going to discuss today: symmetric, skew-symmetric, orthogonal, idempotent, nilpotent. All those matrices we are going to discuss with their properties. So let's discuss them one by one. So first comes a symmetric matrix. So the question arises, what is a symmetric matrix? So symmetric matrix is a matrix, it is a matrix, or I can say that it is a square matrix. It is a square matrix A. Matrix A such that it has this condition that A is equals to A transpose. That means taking a transpose of a matrix does not change the matrix, right? So that is my that is my symmetric matrix. Let's take one example. If I'll take this matrix 1, 2, 3, 2, 4, 5 and 3, 5, 7. Let's say we have this matrix. I'll take a transpose here. This is A matrix. Let's take a transpose. If I am taking a transpose here, what would I get? First row gets converted into first column, 1, 2, 3. 2, 4, 5, first, second row gets converted into second column. 3, 5, 7, third row gets converted into third column. So you can see that here A is equals to A transpose. So I'll say that it is my A is my symmetric matrix. Because I get A is equals to A transpose, it is my symmetric matrix. And one thing you can notice here, that the elements above the diagonal and below the diagonal are correspondingly equal here, right? This 2 gets equal with this 2, the elements below the diagonal, above the diagonal. This 3 is become equal to 2 and this 5 is equals to 5. There is no condition on the diagonal entry. So basically for symmetric matrix, can I write down the definition as Aij is equals to Aji if I not equals to j? Then we'll have a symmetric matrix. So this is my another definition of symmetric matrix, that Aij is equals to Aji if I not equals to j, then A is my symmetric matrix. Let's do one question. Okay, first let's discuss properties of symmetric matrix. First we'll discuss properties and then we'll move to question. So the question says that let A and B be symmetric matrices of same order. Then they are saying that A plus B symmetric. A plus B symmetric means A plus B transpose. I'll take a transpose. So what it would become? A and B are already symmetric. That is A transpose is equals to A and B transpose is equals to B. So I'm just checking what about A plus B transpose. We know one thing, that A transpose plus A plus B transpose is equals to A transpose plus B transpose. So can I convert it into A transpose plus B transpose? And A transpose I already know it is A, and B transpose I already know it is B. So if you do not know the property and you have to you have to just write the option, which of the option is correct, you can just check by yourself. So option first is correct. Similarly for the second one, let's say I have to check that AB plus BA is symmetric or not. AB plus BA is symmetric or not. I'll take a transpose. A plus B transpose is equals to A transpose plus B transpose. So what would I do here? AB transpose plus BA transpose. BA transpose. So what would it become? B transpose, A transpose and A transpose, B transpose. That's how I'll expand it, right? And B transpose is B, A plus AB. So I get the same matrix. So I'll say that AB plus BA is my symmetric matrix. But I can I do the same thing for AB minus BA? Can you guys check that? AB minus BA. Just pause the video and try to check it by yourself, right? I am also checking here. You just try to pause, you just try to check by pausing the video. So AB transpose minus BA transpose, because subtraction doesn't get changed by taking a transpose. B transpose A transpose minus A transpose B transpose, right? What it would become? BA minus AB. So they are not equal. So I can say from here that AB minus BA is not symmetric, is not symmetric, is not symmetric, right? So AB minus BA is not symmetric, but AB plus BA is symmetric. But here you can check that A minus B would be symmetric, A minus B, or I can write down here B transpose is equals to B. I can try to A plus minus B is symmetric. Similarly, A plus A transpose is symmetric, right? You can just check by yourself now, right? Let's do one question based on symmetric. So this is a question they have asked in GATE 2004. It says that number of different n cross n symmetric matrices with each element being either 0 or 1. So I need to find out symmetric matrices of with each matrices either being 0 and 1, and we have given the option power 2 comma n, 2 comma n square, 2 comma n square plus n by 2, 2 comma n square minus n by 2. I need to find out which of the option is correct. See, for a symmetric matrix, I know that A is equals to A transpose. Let's say they ask me to make a matrix, to make a symmetric matrix. So let's say I am making a 3 cross 3 matrix. Let's start with 3 cross 3 and then we'll go to n cross n. So for the 3 cross 3 matrix, this value 1, let's suppose this value I have to fill by myself, these 3 values I have to fill by myself. But when I go for the second row, this value gets filled by itself. How it gets filled by itself? Because it is a transpose, so whatever I have filled here, either 0 or 1, this value would be here. You do not have any permission to change this value by yourself, because if you have already filled this value, these 3 values if you have already filled, so because of this you have a value here. Similarly, again these 2 values you would fill by yourself, and then later on these 2 values, this value would be this value, whatever we have filled here it would come here. Similarly, whatever I have filled in this circle would come here. I do not have any permission to change this, this and this, and then I'll write down the last value. So that means the values which I have permission to change are these white ones. These values, how many values I have? 6 values. 1, 2, 3, 4, 5, 6. And how many choices I have? 2 choices. For this particular position I have 2 choices, for this particular, and let's suppose I have filled here 1. So I do not have any permission to change this value. I have to fill it 1. So I do not have anything to say here if I have filled this value with 1. Right? So for each of the position I have 2 choices. Right? So it would become 2 to the power 6. So how do you get this 6? Now in this 6 you can see that for the first row you need to fill 3 values by yourself. For the second row you need to fill 2 values, or you can say that you have permission to change these 2 values, and then in this you have permission to change 1 value. Otherwise, jo ye 3 values we have filled, we are going to use that only for filling the elements below the diagonal, because for a symmetric matrix the elements above the diagonal are correspondingly equal to the elements below the diagonal. Right? So that's why we have a 3 to 1 choices. Now it is for 3 to 1. If I'll take a 4 cross 4 matrix, again I'll have the same thing. So 4 values I'll fill by myself, and then this value later on would come from here. Again I'll be able to fill 3 values, and these 2 values would come from here and here. Right? So that's why we have 2 and 1 choices. So we have moving like that. N. So for n cross n matrix, if I'll generalize this thing, for n cross n matrix it would move like n minus 1, and it goes up to 1. So that many values I can change. And what would be the sum? N plus n minus 1 plus up to 1. So this is what? This is sum of natural number. What is the formula for sum of natural number? N into n plus 1 by 2. That is, these many values I can fill by myself, n square plus n by 2. Right? And for each of the value I have 2 choices. So the final answer would be 2 to the power n square plus n by 2. That many choices I have, that many possibilities we have, that many number of n cross n different skew symmetric matrix I have. So which option is true? Here option C is true. Right? So this type of questions you have to think about, like they are not going to ask you directly symmetric matrix question. So this kind of question they have used. Right? And also if you guys remember, in the last class we have discussed that if we have a triangular matrix, so minimum 0 values, how would I get? Minimum number of zeros required to make a lower triangular matrix. Lower triangular or upper triangular, any triangular matrix. So we have a diagonal, all the elements above, let's suppose I am taking above triangular. So this entry, these two entry. So we get like this up to n minus 1. So do you remember we get this as n into n minus 1 by 2. So similar kind of a thing, right? We have already discussed that in the last class. So similar kind of this we have the question. Now let's see next thing. Next thing we have here is skew-symmetric matrix. So the question arises that what is a skew-symmetric matrix? Any matrix in which we have A is equals to minus A transpose, or I'll say that A transpose is equals to minus A, then I'll say that it is a skew-symmetric matrix. Right? Skew-symmetric matrix, if I'll take a transpose, it would be equals to negative of A. So let's take one example. Let's suppose this is my A matrix. If I'll take a transpose, transpose would be 0, 1, 2, minus 1, 0, minus 3, minus 2, 3, 0. Right? So now you can see that the elements, okay, but let's find out minus A first, then I'll tell you. Minus A first would be 0, minus 1, minus 2, 1, 0, 3, 2, minus 3, 0. So you can see that A transpose is equals to minus A. So you have the matrix A is skew-symmetric matrix. But one thing to note down here is that the element, all the diagonal entries are 0. All the diagonal entries are 0 and the elements above the diagonal are negatively equal to the elements below the diagonal. Right? The elements above the diagonal are correspondingly negatively equal. If we have 2, then we have minus 2, minus 3, then we have 3. Right? And all the elements on the diagonal are 0. That is one thing. Now, so can I say that the definition of skew-symmetric matrix, first of all, A should be a square matrix. Square matrix. A square matrix A would be a skew-symmetric if A transpose is equals to minus A. So can I say that this definition Aii is equals to 0 and Aij is equals to minus Aji if I not equals to j. Okay, Aii diagonal entry is 0 and the elements above the diagonal are correspondingly negatively equal to the elements below the diagonal. So we have some properties of skew-symmetric matrix. Again, you can solve these properties by yourself, that AB minus BA is symmetric or not, A minus A transpose. Likewise, we have done for symmetric, you can do that. So do you remember when we have discussed about symmetricity, I have said that AB plus BA is symmetric. But in this skew-symmetric, we have AB minus BA is symmetric, skew-symmetric. Right? AB plus BA is symmetric, AB minus BA would be skew-symmetric, and A plus A transpose I have written as symmetric, A minus A transpose as skew-symmetric. So just check this by yourself because it is same. Check once by yourself. Right? So yeah, we have this another question. You are going to just solve it by yourself and let me know the answer in the comment section. Everyone would let me know the solution for this question. And why I am not solving this? Because this is a question similar what we have solved. Using that, I have made this question. The number of different n cross n, let me complete it, skew-symmetric matrices. Number of n cross n skew-symmetric matrices with each element being either 0, 1 or minus 1. You just need to tell me the solution in comment section. Right? So yeah, just try it once by yourself. Okay, chalo, let's move further. Then we have orthogonal matrices. Orthogonal matrices are those matrices, if I'll take a transpose and multiply with the matrix itself, I'll get an identity. So that means A into A transpose, or I'll do A transpose into A, I'll always get an identity matrix. Then I'll say that A is orthogonal. You can check, this example is given to you. You can just check that if I'll take a transpose, what would I get? Cos theta minus sin theta, cos theta. So let's multiply A into A transpose. What would it become? Cos theta into cos theta minus sin theta into minus sin theta. Cos square theta plus sin square theta. What is that? This is an identity, that would be 1. Similarly, cos theta minus cos theta sin theta cos theta, that would be 0. So you can check that it would be an identity matrix of order 2 cross 2. So again, a square matrix is said to be orthogonal if A into A transpose or A transpose into A would be identity, and you would get this as the same thing. You would get it as A transpose A. So this is my orthogonal matrices, right? That is my orthogonal matrices. Now let's discuss some of the properties of orthogonal matrices. So A and B, if A and B be two orthogonal matrices, then AB is an orthogonal matrix. So that means A and B are orthogonal, then AB is also orthogonal. Let's check, is it true or not? A and B are orthogonal means A transpose A is equals to identity, and for B I have B transpose B is equals to identity. I need to check for AB. So I need to check AB transpose into AB. I need to check that for the first one. So what would it become? B transpose A transpose A B. I told you matrix multiplication is not commutative, but it is associative. First multiplying any two matrices does not change the order of the matrix, product of the matrix. So I am writing A transpose A here first. So A transpose A is identity. B transpose identity B. Up identity multiplied it would remain same. B transpose B is again identity. So you can see that AB is my orthogonal matrices. Similarly, if A is an orthogonal matrix, then A transpose is an orthogonal matrix. You can write down this as A of transpose transpose, or let's say A transpose into A transpose transpose is equals to identity. So A transpose is my orthogonal matrix. This is also true. Inverse of an orthogonal matrix is orthogonal. That is also true, and identity is also an orthogonal matrices. So these are all the properties of orthogonal matrices. Now let's discuss idempotent matrix. A matrix is said to be an idempotent matrix if A square is equals to A. If I'll take a square of a matrix and I'll get a matrix itself, then that is called as idempotent matrix. Now you guys are thinking, okay, only identity or either 0 or 1 we have entries, then it would be possible that you would get A square is equals to A, but that is not true. If you would solve it here, let's say this is my matrix A and I am trying to find out A square. So I need to multiply this matrix with 4 minus 2, 6 and minus 3. So what is my A square? A square, if I'll multiply 4 into 4, 16 minus 12, I'll get 4. 4 into minus 2, minus 8 plus 6, that would give me minus 2. 6 4s are 24, minus 18, that would give me 6. Minus 3 into minus 2, that means 6 minus 9, that would give me minus 3. So A square is equals to A. So A is an idempotent matrices. A is here my idempotent matrix. Now properties of idempotent matrix, that if A transpose is idempotent, then A is idempotent. So that means A is idempotent if and only if A transpose is an idempotent. You can check that na, why it is true. So if A square is equals to A, what you are doing? A square is equals to A, just take a transpose on both sides. A square transpose or A square. Either I'll take a transpose first or square first, it does not matter. I can write down this as A transpose square. Idhar bhi to lena tha. This is A transpose. So we are getting A transpose square is A transpose, so A transpose is idempotent. They are saying that I minus A is idempotent if and only if A is idempotent. So let's check. Let's take A as an idempotent matrix and I am checking for I minus A. I am checking it for I minus A. So I minus A square. How would you expand it? I square. Right. So basically you cannot use A plus B square, A square plus B square plus 2AB. You cannot use that formula because A and B are not commutative. Right. Here we have identity matrix, so it is commutative, but still there might be a possibility that you can have another matrix, so you cannot expand the square. So I'll not use generally this square method. So I minus A into I minus A, I'll multiply I into I square, minus I into A, that would be A itself, minus A into A itself, and minus A into minus A plus A square. So A square is A. A square is A. So I get I minus A and plus A. A and A get cancelled. So we are left with I minus A. So you can see that here. A is idempotent if and only if I minus A is idempotent. Right? So these are two properties we have for idempotent matrices. Next we have is involutory matrix. Any matrix in which we have A square is equals to identity. If I'll take a square of a matrix and it would become identity square matrix. ठीक है, involutory में square की जरूरत नहीं है. If we take a square of a matrix, if I have A square is equals to identity, so involutory matrix may or may not be square, right? May not be a square matrix. So if I'll take A square of a matrix and I'll get it as an identity, then we'll say that it is my involutory matrix. And what are those properties? Square matrix A of any order is said to be involutory if and only if A square is equals to identity, right? So or A is equals to A inverse if determinant is non-zero. वो हम आगे डिस्कस करेंगे. A and B are two involutory matrices of same order. Then AB is equals to BA and AB is equals to BA. Then AB is also involutory matrices. So they are saying that, let's suppose A is involutory, A square is equals to identity and B square is equals to identity. They are saying that then AB is on involutory. AB is involutory. So for that you have to check AB square. So AB square would be, how would you take this square? So basically AB square, you cannot expand it directly, it would be AB into AB, but because of matrix associative property, you can write down BA into B and AB is equals to BA is given. So AB and B. So it would become A square, it would become B square, it would become B square. So it would become A, it would become B. So A and B are involutory. AB is also involutory matrix, but with the condition that AB is equals to BA. Determinant of an involutory matrix is either -1 or 1. We'll discuss in detail about the determinant when we'll discuss the determinant topic. Now, next thing we have is this question. They are saying that if A and B are orthogonal matrices of same order, then A plus B is orthogonal, A minus B is orthogonal, AB is orthogonal, AB plus BA is orthogonal. I just need to check that which of the options are correct here. So what would I do? I'll start solving. So for A plus B, I know that I need A and B are orthogonal matrix. So A is equals to A transpose and B is equals to B transpose. I know this. A is equals to A transpose, B is equals to B transpose. Oh sorry, it is for symmetricity, na? A is orthogonal. So A transpose A is equals to identity, and for B matrix it is B transpose B is equals to identity. So I know that because A and B are orthogonal matrix. Now let's check for A plus B. So if I'll go with A plus B, I'll multiply it with A plus B transpose. A plus B. So it would become A transpose plus B transpose into A plus B. What it would become? A transpose into A plus A transpose into B plus B transpose into A plus B transpose into B. But this is not becoming an identity, like it does not seem it is an identity. This is identity A transpose B, B transpose A, and this is an identity. This is not becoming an identity, so I can say that option A is incorrect. Option A is incorrect. Let's check for A minus B. Similarly, you would not get A minus B as your orthogonal matrices. You can just check by yourself, because you do not get A plus B as orthogonal, A minus BB you would not get as an orthogonal. AB is also orthogonal. They are saying that AB is orthogonal. That means AB transpose into AB. ये तो हमने check कर लिया था ना? We have already checked that. So B transpose A and B, A transpose A identity, then we have B transpose B, and it is also becoming an identity. So C is correct, B is incorrect, C is correct. Let's check for D, because there might be a possibility, na? This question can be MSQ, because there is nothing mentioned here. So let's check for AB plus BA. AB plus BA you would take a transpose of this and you would multiply it with AB plus BA, right? AB transpose B transpose A transpose plus A transpose B transpose, because A plus B transpose हो गया, and you would multiply it with AB plus BA. Let's multiply AB B transpose A transpose AB, and then A transpose B transpose AB, and then B transpose A transpose BA, and then we have A B transpose A transpose, sorry, we have last term A transpose B transpose BA. Now again this term would become identity because A transpose A is identity, B transpose B would be identity, this would be an identity. But how would I make this as an identity? Because I do not know that A and B are commutative, that A and B, if I'll do AB and BA would be equal, or A into B transpose would be equals to B transpose into A, that I do not know. So that's why this is not becoming an identity completely. So this is not an orthogonal matrices. So here only option C is correct, right? Here only option C is correct. So these are all types of matrices I have. We have one another type of matrices which you need to remember. I am writing it here. That is your nilpotent matrices. Nilpotent matrix. That is not mentioned in the slide, so I am writing it here. Any matrix A, square matrix A, square matrix A is nilpotent, if you are able to find out a number n such that A to the power n would be a null matrix. If A to the power n you would get as a null matrix, then you would have that matrix as a nilpotent matrix, right? So just remember that if in case in any question they would like mention that a nilpotent matrix. If you would get a matrix A such that A to the power n is equals to null matrix, A is not a null matrix but A to the power n is becoming a null matrix, then you would say that it is my nilpotent matrix, right? So these are all different types of matrices. Now in next session next video we are going to cover determinant and properties of determinant, and then we are going to also solve some gate level question. Okay, so that's all for this video guys, and if you have any doubts or anything you can just let us know in the comment section. We check our comment section regularly, so we'll get back to you, or we can discuss it on our Telegram channel, anything where, right? So yeah, we'll be able to help you if you just let us know that what problem you are facing in solving question or any another thing. So let us know that. Okay, so yeah, that's all for this session guys. Thank you for joining.